And with that, I'm going to introduce Zachary Bobroth, if he's ready. Are you ready? I'm sorry. Zach is going to be talking about using capsules for firmware configuration update. Thank you.
So, we'll be talking about capsules, using them for firmware configuration update. So, to go through the list of the agenda, a brief introduction to this feature, a history of BIOS and UEFI firmware setup, UEFI capsules, putting it together into what this feature is, some of the security considerations behind it, and then the call to action for the group that's in this room. So, without further ado. So also, talking about blackouts, I appreciate everybody's effort in getting the UEFI 2.8 specification approved. Otherwise, my presentation would not have been possible. So, UEFI 2.8 added a new capsule type. It allows for the the exchange of configuration data between the operating system and the UEFI firmware. The main way they implemented this is there's two sides. The operating system needs to have information from the firmware, and the firmware needs to get information back from the operating system. So they implemented this. It all starts with the EFI OS indications flag. They added a new one called JSON config data refresh. Whenever this is flagged by the operating system, the firmware will now take the HII configuration data or other configuration data it's looking to expose and publish it on the system configuration table. The OS can then pull that information and can then make use of it, manipulate it, and then provide information back to the firmware via capsule. So it uses EFI OS indications and capsules and the system configuration table, and that's basically the whole process. But what does this mean? So the UEFI spec is very abstract when it comes to defining what configuration data is. It basically doesn't typify it at all. So the most obvious use case is the HII configuration data, because in UEFI that's the real configuration data. But it could be extended to other uses as well. Now what could the OS do with this? The OS could provide a visual display, command line display, or whatever type of interface it wants to all of the exposed configuration data. This works extremely well for headless systems. It can also be very useful to have a clean integration between your firmware settings and your operating system settings. They can almost be dependent upon each other. When you change one, it forces a change in the other location. It can add a synergy between these things. So, as you can see by this brief introduction, it's a powerful new feature, but with any powerful new feature, there are certain security measures that must be implemented as well. So, now a brief history on BIOS and UEFI firmware setup. So, we all refer to it as legacy BIOS, but it's basically the 16-bit assembly BIOS. It's existed since the early days of x86 firmware. Every implementation was proprietary. When you worked with vendor A, B, or C, it was different, and it provided different look and feel, different levels of features, and functionality. So depending upon who you bought your computer from, the configuration was completely different in what its capabilities could be. To further complicate the situation, plug-in card vendors, I know there's a lot of them in the room as well. They also provided their own pre-boot configuration area that had a different look and feel, a different functionality. Sometimes it worked, sometimes it didn't. This was a mess, I guess you could say. So UEFI really stepped in to help this, but here's a couple pictures of legacy BIOS. One of ours, one I took from Wikipedia. And now we move to UEFI. So when UEFI was introduced, the specification architects wanted to provide an abstract or clean method that was inclusive for the firmware configuration. Data from any driver that's executing in the firmware or during the pre-boot environment can export data to the HII in what are called HII packs. And then the firmware itself provides a browser that is able to view this data. It's almost like the World Wide Web is the data, and it's either Firefox, Chrome, Internet Explorer, whatever you want to call it, that you're looking at in your browser. It still allows a high level of customization, but it has a common set of features that forces the community to work together. So here's another picture. As you can see, this is ours again. If you go back a few slides and you go forward, it's really not a different look and feel for the most part. You can really make it look however you want, and most of the vendors in the room probably chose a similar look and feel to their old ones to not disrupt the community. But you can offer all different looks and feels. If you go to a computer store today and buy any number of different computers, you can see everybody does setup in their own look and feel, but they conform to the standards. It also, the architects added in a high level of extensibility, as they talked about. So third-party firmware components can publish their own set of questions, and it fits right into the framework. Having the one HII database allows the one setup browser for the same look and feel for all components in the system. So you don't have to worry about if you plug in a card from vendor A, B, or C, it's still going to look the same. The questions may be different, but you won't be worried about how to use it. And HII has been obviously revved over the years, but it allows a demanding level of configuration features, and it also pushes the industry into this common set of features and standards. The forum also went ahead and added further things. In UEFI 2.5, they added the EFI config keyword handler protocol. This protocol allows an easy method of configuring options on your platform based upon keywords without having to know the exact setup structure you're modifying, without having to know where this data is stored, but basically providing you that building block that says keyword A, legacy, or let's not say legacy, UEFI network boot. You can enable or disable that as a capability by a generic keyword, as opposed to having to know I need to go into this setup structure, modify these values, and store it back to this location in SPI. So it allows for script-based configurations even. You no longer need to worry about what driver/code publishes the configuration knob. It's now just a generic knob. And you can use this to configure it from anything in the pre-boot space. Even UEFI shell applications could take advantage of this. So you have your platform config and your HII data, and the keyword protocol builds on top of those together to allow you this ease of use. So that's the brief history on firmware configuration. On to capsules. So capsules were introduced in UEFI 2.0. Basically the first time that it was UEFI. Capsules were binary blobs of data that the OS could pass to the firmware. In other situations, the firmware could pass to itself. Basically, if it needed to reboot during its initialization and pass some data to the next reset, it could use these. Also, Update Capsule is a runtime service, but I would say most implementations typically only allow processing of the capsule prior to exit boot services. So it's kind of one of those strange services that bleeds between runtime and boot service time frame, and it can offer different levels of functionality. But capsules remained fairly limited in the early days of UEFI for some proprietary data processing or passing. They weren't heavily used until around the time of UEFI 2.3.1c. When UEFI added Secure Boot, we now had the ability to do cryptographic algorithm standard. There were a number of different things that were available generically that may not have been in everybody's implementation prior to this. But basically, NIST 800-147 mandated now that all firmware updates to comply with the standard must be signed correctly, must be verifiable, and basically secured the process for firmware updates in the system. Basically, everybody realized that the best method to pass a firmware image back to the firmware from the OS or through a reboot cycle was to use a capsule. So this became the most common used method for capsule updates. And you'll see a lot of that even more with ESRT using SM or FMP updates for plug-in cards. This exists throughout the market today, and I would say you guys have probably seen at least a dozen or 2 dozen speeches on it in the past 2 years. Or a few years, sorry. So putting it together now. So we're talking about JSON configuration data. So the current configuration data export. So what is my current configuration? How does it get exported to the OS? So the OS sets the OS indication bit requesting the configuration data we had on the first slide. Then the system reboots. The firmware processes the OS indications bit stream. The firmware publishes the current, or publishes a pointer to the current configuration data on the system configuration table. And with anything on the system configuration table, is it boot time, is it runtime? This is one of the ones that is runtime, so you need to make sure that you allocate your space correctly for a feature like this. The OS then boots later on and takes control, finds the data on the system configuration table, and then through whatever means the OS intends, it allows the OS drivers or applications to find this data, process this data, do some manipulation on this data if they so wish. So on the reverse, how do we get the JSON data back from the operating system? So update capsule is called with optional system reset. The standard UEFI PI capsule processing takes place because this isn't the only form of capsules. They're all processed at the same place. The capsule is recognized as a JSON capsule. The JSON capsules are placed on the system configuration table. It can provide you more than one if you have more than one consumer of JSON data, as an example. And the spec goes into detail of how you provide basically either a single pointer to a JSON data, or you provide a size and then a number of pointers next to it, pointing to all the different capsules. UEFI drivers check the system configuration table and then process the data. So it could be the network stack driver is saying, oh, somebody wants to change the network stack to be on. It will then take that data, use the keyword protocol to change its request, and then pushes the data out to NVRAM. If it requires a reset, it can also take care of it at that point as well. But the extra part of this is that the drivers need to install results from the JSON processing back on the system configuration table. I suppose this could be optional, but if your OS wants to verify that these changes were successful, or that these changes, or what sort of error processing there might have been, you would probably want to publish a blob that then gets interpreted by somebody who understands it. So what are some considerations beyond the data capsule for the JSON data? As we already talked about, multiple JSON config capsules are provided. An array of pointers is located on the system configuration table. But the UEFI spec was quite clear in their definition of the JSON data is undefined. The schema is defined by the consumer and producer of the schema. So, however, it's saying that it's JSON data. If you look at what's in the struct in the lower right there, you can see that it is configuration data length and just an array of uint8s that's the configuration data. I would say JSON's probably the industry standard to use for something like this today, but you could extend it to something else if you wanted to. And here's a quote from the spec. It is expected that particular drivers have the specific knowledge of the JSON schema used in the payload so that they can describe system configuration data in JSON, then install to the UEFI system configuration table. So you're expected to know your own schema and use your own schemas. And this all allows for more flexibility than just HII configuration data. Obviously, what I'm focusing on in this presentation is HII, but if you wanted to do something else, you could. So what does this mean for most people in the room? Because this really impacts, I would say, the UEFI drivers, writers, and the OEMs in the room the most. Obviously, the OS guys need to be somewhat on board for this whole thing to work, but you first need to figure out, what does it mean to you? First, make it easy for yourself. You can have a driver be called back if when your driver runs, the data is not already on the system configuration table, you can set up an easy event with the GUID of the item you're looking for on the system configuration table, and then you get notified when this thing is installed on the table. So that makes it easy. Also, we've been talking about the keyword protocol. Standardization is very useful when it comes to these things. So the UEFI group, or UEFI work groups, and DMTF have been working hard to create a standard set of keywords for known quantities. So RAID mode enable, or 10 gig enable, all of these standard options that may be card specific or specific to certain vendors' cards. The question itself can be generic, and if you use this keyword, then it allows you to write your drivers more simply. It allows the JSON data to be more standard, and also it allows somebody to manage non-homogeneous hardware in their data center or in their facility as a network admin without having to worry about, is it a vendor A, B, or C? I can now just enable this setup option across everybody with a capsule that's deployed across all the systems. So now we get to the more complicated part, the security considerations. So Capsule Trust. Still today, the most common use of capsules is a firmware update. As we already talked about in the NIST specification, all firmware updates must be signed and must be verifiable. The signature offers a safe level of security so that you know that this came from an authentic source and it wasn't changed from when it was in transit. It's the same all the way through, and you can do tests with these sorts of things, change a few bits, and then you'll see that the capsule's rejected. But this is an example of where the capsule can be created on demand in the OS and passed back to the BIOS. Can this be trusted? This is where you might want to look at how much you expose. Because if you expose all of the system setup, the capsule might change firmware settings to put the system in an unbootable state. And you didn't even realize this happened because it was a standard reboot, came back around, and now it doesn't boot anymore. It could change settings related to security components. Not necessarily secure boot, but it could turn off the TPM. It could do all sorts of different settings related to this. You could change the firmware settings to slow down or delay booting. It might not be obvious, but it could, say, change the clock speed. It could do all sorts of things with that. And it could also remove or add boot options without you realizing it. So, how do you mitigate these types of security issues that can come up with these capsules? Obviously, the first step in mitigating security issues is you limit the attack vector. Don't expose questions that don't make sense to be modified by the operating system. If you need some sort of physical presence there to verify the user's there to do something, leave those settings in a way that somebody has to be there to enter setup and to change those settings. So just some sample things is UEFI secure boot, TPM, and other device enable disable options could be exported, but don't allow those settings to be changed via the import, for example. And can these capsules be signed and trusted? This is a question that I don't really have a great answer for in this presentation. So you could use the signature database, whether it be DB. DB is the one that everybody knows, but you could use an additional authenticated variable that you manage your own signature database in. Could be extended with additional public keys. The private key pair could be used to sign this configuration data so that it is now an authentic capsule and you can trust it and it came from somebody. In a corporate environment, this makes sense because the network admin can go ahead and manage these capsules, publish these capsules to the systems, and then the systems will all have the same public key inserted into them. In a non-corporate environment, are you really going to trust your end users to protect their private key on their own computer, whether with a USB key or storing it somewhere on the hard drive? And this is when we're just talking about the basic information. Now, if you start going to a plug-in card vendor, they want to use this to configure some of their RAID volumes or some of their network capabilities. How do they make use of this? It starts to layer on more and more complicated things. So this kind of leads to my call to action of firmware configuration capsules. Obviously, as you can see, open up all sorts of new capabilities for firmware configuration. These features will be very powerful, as you can see, and they must be secure. So I would suggest that all UEFI stakeholders, including the operating system vendors, OEMs, and IHVs work together, IFVs as well, to describe the best methods to make these secure, useful, and continue to improve the features of their platforms. And that is that. So, what kind of questions are there? All right, we got lots. So we got a couple.
I'm just a little curious. Why JSON instead of CBOR?
I was not in that meeting. But I would just say it seems to be the more common past format, and we probably overused JSON already with some of the REST implementations that were in the UEFI spec, but I wasn't in the meeting that decided on this.
We were doing REST and redfish stuff, so JSON just came along for the ride.
Yeah.
Ah. Okay.
Yeah.
So, as I understand it, the design behind HII was to try and have a large number of abstraction layers so that you could do things like publish forms and then consume them in all kinds of different browsers. You disentangle the strings from the configurable so that you can have all kinds of languages and so on. And in some ways, this makes sense. Now, this configuration capsule is using an entirely black box JSON inside that is up to the consumer and the producer, who is the same person, to define. So it seems like we are going back into the land where all the various OEMs and all the various driver writers will go in 13 different directions and come up with ingenious, differently awful things. Is there any suggestion about how we might prevent this and how we might, because otherwise, you know, in 4 years we'll be back here saying this is all awful, can we just have some standard now, please?
I would agree that it does open you up to the capabilities to use these things, but I would also bring these things up in the specification work group and try to base it on as many of the standards that are there, using the keyword protocol to standardize on what your settings are that you allow changing and everything like that. It does open it up to whatever black box you want to be on either side of things, so you're correct.
And that is a item of contention as far as the keyword definitions, who owns them, EMPF versus UEFI versus other areas. So everyone has opinions about the config, everyone has their own views, and we're trying to work out the compromises, but that takes time. So.
Of course. No, of course. The floor is yours.
I just wanted to make a comment about the history of setup.
Sure.
Because you reminded me that in the early days there were systems that had set up on floppies.
Mm-hmm.
And if you lost the floppies, you were just totally hosed.
Yeah.
But,
So we're still headed in the right direction to.
Right.
Yeah.
So just want to make sure I answered this correctly. To read the current configuration, the process is you set a flag in OS indicators, reboots, and then resets.
Yeah, I would say that most OSs, if they're looking to use this regularly, will probably continue to set that flag.
Okay, is there any reason not to just export it always?
I guess it does use up runtime memory. So
And
if
you
the
can
OS,
always put it in boot services memory, and then the OS could copy it
if it was looking to
wanted
make use of it, but then you're in the same case of where does the OS know at that early boot stage that it's looking to make use of it?
And we can also just do that.
Exporting always also takes time.
Yeah, that's true.
And if the OS wants it all the time, you can always just request it.
Yeah.
well, but you need to do one reboot cycle in order to get it,
Oh yeah,
Yeah.
definitely. Yeah.
which if
So,
you,
so the OS installer can't see it. Yeah.
right,
Yeah.
your first boot doesn't see it.
Yeah. Other questions?
So you brought up Secure Boot. Even after all this time with, say, Secure Boot enrollment certificates, that's one of the things that people tend to have an issue with as far as fleet deployments, where they get a lot of systems and they have to go in and in bulk change their certificate configurations. and we haven't, in code or in practice, in the specs, standardized the way that those things are deployed. There's no standard container format that all setups can take to say this is my secure boot configuration for import or export. I was hoping that Capsules might help with that as on a first-time enrollment. So is there a scenario you could see where you have a system that's still in setup mode, and there's a way to use this to do kind of the bulk enrollment of, hey, here's my custom capsule config?
Yeah. I mean, yeah, you could use auto mode, or you could use this for it, but I would make sure that you design it very, very specifically. Because you don't want to end up in a scenario.
Yeah.
Yeah.
Oh no, I see the huge downside of using this, but
Yes.
I also see a lot of people looking at it going, this is exactly the thing I would want to use this sort of scenario for. Therefore, is there a way that we could set up the implementation so we all look at it before someone else does it the really bad way?
Agreed.
And we end up watching this at Black Hat.
Yeah, and I mean, I would say that when we started writing this presentation and started working with this, we didn't have these end slides in the way that we intended them to be.
Okay.
As we worked our way through it, we found some issues with the spec, and we even noted them before the final spec was published, which we got them through. But I would also say that, like, I put DB on this slide for signature database, but I'm not advocating using DB for something like this. I would use PKCS7 verify functionality in your own variables to verify your own capsules. It's just, this is the one that everybody knows, I guess is the easiest way to say it.
So I think, Mike Kinney, don't we have a presentation up from Laravel Connect on this using PKCS7?
Yeah, basically you can use your own custom key store to verify a capsule, basically. Yeah. Other questions? Okay. I guess I will release you back to testing, and I think the speaker office hours start in 30 minutes? Yep. Okay. Thank you, guys.